So here we have the fifth root of 64. You see a number, and in a problem like this, the first thing we'll do is break down the number. So 64 is 8 8 is 64. So that's 2 times 2 times 2, which is 8, and then 2 times 2 times 2, which is 8. So there's 2 to the 6th power. Now remember that the fifth root of anything, if you had to write it with a rational exponent, it would be something to the fifth power, right? And let's say the inside is a multiple of 5. Then you know it's going to be 2 to the 10 times 1 over 5. 5 goes exactly 2 times, leaving a whole number, and your final answer is 2. But what if it is 2 to the 11th power, to the 1/5? Instead of writing it as 2 to the 11th whole to the 1/5, you could say, okay, what is the closest multiple of 5? It is 10. That's the largest multiple of 5, and plus an additional 1. And if you had to break it down using the rule of exponents, this is the same as 2 to the 10 times 2 to the 1, and now that's whole to the 1/5. Again, using the rule of exponents, if two numbers are multiplied together, then each number is raised to the 1/5. So it's 2 to the 10 whole to the 1/5 times 2 to the 1 whole to the 1/5. 2 to the 10 whole to the 1/5 is 2 to the 10 times 1/5. 5 goes 2 times into 10, so that's 2 squared. And this is 2 to the 1/5, which is really the fifth root of 2. So what we've done is we've simplified this expression as much as possible. So if there was a perfect fifth power sitting inside, we brought it outside the radical sign, and this is what we have as our final answer. Now if it's 64, we broke down the 64, and we know that 64 is 2 to the 6th power, and it's the fifth root of. And by definition, the fifth root is, if you had to write it as a fractional exponent or a rational exponent, it would be to the power of 1/5. 2 to the 6, I want to write it as 2 to the 5 plus 1, because 5 is a multiple of the denominator here, which is a 5. 2 to the 5 plus 1 by rule of exponents is 2 to the 5 times 2 to the 1 whole to the 1/5. And the reason why we broke it down this way, you're going to see in a second, is 2 to the 5 to the 1/5 times 2 to the 1 to the 1/5. So this is equal to 2 to the, cancel the 5s because you're multiplying the 5 with the 1/5. So that's 2 to the 1, and this is 2 to the 1/5, which is the same as the fifth root of 2. So if you put it back in the radical form, it's going to be 2 times the fifth root of 2. So you've completely simplified this radical expression. Now look at the next one. Let's break down the 48. 12 times 4 is 48. 3 times 2 is 6. 6 times 2 is 12. And 2 times 2 is 4. So if you multiply all these together, this is 3 2s are 6, 6 2s are 12, 12 4s are 48. So I can write this as the fourth root of 2 to the 4th times 3 to the 1. So 2 to the 4th times 3 to the 1 whole to the 1/4, because that's what the fourth root means. So that is 2 to the 4th whole to the 1/4 times 3 to the 1 whole to the 1/4. Simplify by multiplying exponents. So that simplifies to 2, and this is 3 to the 1/4. So this is equal to 2 to the 1 times the 4th root of 3. So this is the simplest form in which we can write the radical expression. Let's look at the next one. Break down the number. 32 is 2 to the 5th power, if you break it down. Because 2 to the 4 is 16, 16 times 2, so that's 2 to the 5th power. 16 times 2 is 32. Now, y to the 7th, I'm going to write it as the largest multiple of 5 less than 7 plus the 2. So this is equal to 2 to the 5th y to the 5 times y squared whole to the 1/5. And this is equal to 2 to the 5 whole to the 1/5 times y to the 5 whole to the 1/5 times y squared whole to the 1/5. And now you see why when you multiply these two, the 5 and the 5 cancel, multiply these two, the 5 and the 5 cancel. And that's the reason why we wrote y to the 7th as y to the multiple of 5 times y to the 2. So now simplifying, we get 2 to the 1, y to the 1, and y squared is to the 1/5. And if you want to put it back in the radical form, it's going to be the 5th root of y squared. Let's simplify the first one. It's the 5th root. So I'm going to write x to the 6 as x to the 5, which is the largest multiple of 5 less than 6, plus 1. Y to the 11, I'm going to write it as the largest multiple of 5, which is 10 plus 1 whole to the 1/5. And you've seen earlier why we do this. So I'm going to write this as x to the 5th times x to the 1 times y to the 10 times y to the 1 whole to the 1/5. Now by the rule of exponents, each one of these numbers is raised to the power of 1/5. And x to the 1/5, y to the 10 whole to the 1/5, y to the 1 whole to the 1/5. So this is equal to, when we multiply these exponents, because that's going to be 5 times 1/5, the 5's get cancelled. 5 goes 2 times into 10 when we multiply the exponents. And finally, we have x to the 1. We have y to the 2. I'm going to write this one next. And then I'm going to write the x to the 1/5, y to the 1/5. So this is equal to x y squared times the 5th root of x times the 5th root of y. We can combine these two and write it as xy squared times the 5th root of x times y. And that's the simplest form in which we can write this expression. Let me just write this here. The cube root of 40 x to the 4th y to the 7th. So 40 is 4 times 10, so that's 2 times 2 times 5 times 2. So that is 2 cubed. And remember, we're looking at the 3rd root, so that's good. because it's going to cancel with the 1/3 times 5 to the 1. So I'm going to write this as 2 cubed times 5 to the 1 times, I'm going to write x to the 4th as x to the 3, which is the largest multiple of 3 less than 4, plus 1 times the largest multiple of 3 less than 7 is 6. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, which is too big. So we have 6 plus 1. Now by the rule, this is the cube root. So this is, the cube root is written in the fraction as a fractional exponent of 1/3. So that's 2 to the 3rd times 5 to the 1 times x to the 3 times x to the 1 times y to the 6 times y to the 1. So this is equal to 2 cubed to the 1/3, 5 to the 1/3 times x to the 1/3, I'm sorry, x cubed to the 1/3 x cubed to the 1/3, and then you have x to the 1/3, y to the 6 to the 1/3, y to the 1/3. Now let's see, these two multiplied together cancel each other out. These two multiplied together, the exponents multiplied cancel each other out. 3 goes 2 times into 6, which makes it a whole number. Now we're going to write all the terms with the whole number exponents on one side. So 2 to the 1, so I've written this 2 to the 1. Next I'm going to write times x to the 1. Next I'm going to write y to the 2. And next I'm going to write all the terms containing a rational exponent. So that's 5 to the 1/3, x to the 1/3, and y to the 1/3. So these are the leftover terms. So that's 5 to the 1/3, x to the 1/3, y to the 1/3. So we've written down all the terms now. Let's combine and write the expression, and this is equal to 2x y squared. I can combine all three terms and write it as 5x y to the 1/3, and this is equal to 2x y squared. And I can write this back as a radical expression, and that's the cube root of 5xy, and this is the best way in which I can simplify this expression. Let's do this problem. If there's a number, break it down and write it as 2 cubed 3 squared. So since this is the square root, it's going to be to the half. So I'm going to write 2 cubed as 2 squared times 2 to the 1, and you've seen why we do that. We want to have exponents as multiples of 2, and that is 3 squared. A to the 4th